So, thank you very much, Bobby. Last summer, our colleague George was in London, and he had the chance of visiting Palantir Technologies. He came back very impressed, and he told me, like, we really have to bring these guys at How to Web. What they're doing in terms of product is fabulous. We're very happy that we managed to bring them here and How to Web. And I'm inviting here on stage with me Adam Borochoff. He came all the way from New York, and he's going to give a talk on product strategy and how to build data-driven products. Adam, the floor is yours.
Thank you very much for that intro. It's my first time here at How to Web, and so I'm very excited to be here and talk to you guys about my team. As was mentioned, my name is Adam Borochoff. I'm the chief engineer on the forward deployed product engineering team at Palantir. And today I'm going to talk to you about what that means and also about a product that we built called Contour. And one of the most interesting things about it for me is how different that is from what you'd expect enterprise software to be built. But first I want to talk to you a little bit about Palantir. Palantir was founded in 2004 by people coming out of PayPal. And the core thing that they did at PayPal wasn't just build an online payment processor. It was how to do it while not getting defrauded in the process. They were a startup that was losing something like 20% of their revenue to what they told me was what they thought was the Russian mob. Whether or not that's true is for the history books. But there's clearly a problem that they had to solve in order to survive. And so they did what any startup would do, is they would use industry best practices to solve this problem, which at the time was find automated fraud detection solutions. So they deployed these, and what they noticed was the mob was able to get around them every single time they updated the algorithms. But they noticed something interesting. Whenever they sent a person to figure out what went wrong with the algorithm, the person was actually doing a really good job being really quick at finding out what the algorithms missed. And so what they ended up doing was building a system that let computers do what they're good at, triaging millions of transactions, and let humans do what they're good at, determining what the novel fraud looks like. And this system worked, and PayPal was eventually sold to eBay. But this is actually a pretty cool insight about the limits of computers and what humans are capable of. And as it turns out, this insight extends into many different industries. Fast forward to the terrorist attacks of 9/11. One of the core failings of the government wasn't that they didn't have the right data to prevent the attacks. It was that it was a technological problem and a policy problem. If only they could share the data. One of the things that the PayPal alumni has realized is that the computers weren't going to find the terrorists, the humans had to. Thus, Palantir was born with the mission of taking humans and computers software working together to counter terrorism. A few years ago, we actually started expanding beyond just the government, taking the same underlying principle of humans and computer software working together into almost every industry. We initially started out in areas that were very similar to the work we were doing in government, things like credit card fraud or cybersecurity. But we've since wildly expanded into different use cases. And one of the things that allowed us to do this was basically all places have very similar problems. They have tons and tons of data. They have many different databases, and these databases weren't designed to be analyzed from the beginning. We would notice things like we would go to places and find mainframes that were built in the 70s. We even went to a bank that didn't have unique identifiers for their customers. And all these things that you kind of expect of your data coming from the technology industry. These places, you had to model your data, you had to refine your data. Step one, or rather step zero, is make the data make sense. Next, we have customers that need to use the data. You can't just integrate all the data and go up to one of the customers, non-technical customers, and say, hey, I've integrated all the data, it's in this database, have at it. These guys are petroleum engineers or they're signals intelligence analysts. You have to communicate through an interface that they understand. So frequently when we go to new verticals, we bring the products that we've built with us. And with slight modifications, things that were designed for petroleum engineers can be used in healthcare. Things to combat fraud can be used in border control. Every so often, when we go to a new place, we find a product, we find the products that we do have aren't good enough to solve the problem. And that's where my team comes in. We are basically designed to go from 0 to 1 in less than 6 months on any given problem. And frequently when we do have a customer that has this problem, we find that they've been trying to solve this problem for years, have failed, and are now in crisis. In 2014, this particular customer happened to be a government defense agency. And government defense agencies have a ton of data. And unlike most government agencies that you work with, they have to respond very quickly to problems that arise. They also have a large amount of non-technical analysts. And what I mean by non-technical is it's kind of like your parents. They don't know how to code, they don't know SQL, and when they're using the keyboard, they're probably only using 2 fingers at a time. So basically, these guys have a ton of data in their databases, and they don't know how to query them. When we showed up, their workflow looked something like this. The analyst would come up with a question they want to ask, a question such as, are citizens going to Syria? And if they are going to Syria, are they talking to anyone bad? They would tell those questions to database administrators, and the DBAs would convert that question into code, run the query, which could either take on the order of 2 hours to several days, get the results back, take those results and send it back to the analyst who had the question in the first place. So then, only then, can the analysts begin to start doing their work. So obviously, this is pretty bad, but it does provide us a good opportunity. How can we build a product that has tons and tons of data and is usable by non-technical users so we can cut out the DBA middlemen? As many of you out there know, one of the scariest things to be both an operator and a designer of a distributed system are non-technical users who don't understand the destructive powers of the Cartesian product. So three of us, including myself, actually embedded with the analyst. And within 3 months, we had built Contour, or at least built the beginnings of Contour. And I want to show you what that looked like. So this is Contour, and this is actually what it looked like 3 months into the product. And I actually went back into our code base, built the product 3 months ago, and then loaded this taxi data that you're looking at now. The taxi data is actually real data. It's released by the New York City Department of Transportation. You can go download it yourself. And as you can see here, Contour provides you an action bar of different tools and different widgets, so you can easily visualize, aggregate, and group by data. Something that you can't tell from the video is we actually provide a ton of guardrails in the product to prevent users from bringing back too much data to the browser and crashing it, or creating a query that'll deadlock the database. So none of our customers, as far as I'm aware, actually use the taxi data, but I find it's a very good proxy for the questions that they do ask. For example, the question that I'm trying to answer here is, what's the worst time to go to JFK? Because I do that so much. But in the process, I actually learned several things. One is that the GPS data here is actually incredibly dirty. If you actually go out into the map, you can see there's a bunch of taxi pickups that claim to come from the middle of the Atlantic Ocean. The other thing I found out was which taxi driver over the time period made the most money. And within a few clicks, I was actually surprised to learn he actually makes more than $30,000 gross. $300,000 gross. A lot more impressive. It's cool. And so at the end of the video here, you can actually see that we save the different actions that the user has taken. And this is incredibly important for government departments. One, for the first reason is you need to police usage of your system. Too many people potentially use this for evil, and you need supervisors to go through and make sure people aren't doing anything bad. The second is, because of the decisions that these agencies are making that are so important, you need to be able to track back. You need to be able to track your decisions back to starting data and make sure that what you have is grounded in truth. So this is Contour, and no presentation is complete without a up and to the right graph, and so here it is. Contour is a platform for top-down analysis. It's designed to be used for on very, very high-scale data. So billions of billions. We haven't quite hit trillions yet, but we're hoping to get that sometime soon. As I mentioned before, there are a very diverse set of users using this product. We have the signals intelligence analysts that are using this to find suspicious behavior. We have actuaries that are trying to find out which insurance policies are losing the most amount of money. And we even have engineers at Palantir using this for data integrations. We didn't build Contour in Silicon Valley with a huge development team. We built it with just the 3 of us out in the field. And on the back end, we use Spark, which is a distributed compute system, largely the successor to Hadoop. And on the front end that you saw, we used Angular and TypeScript. So how did we do all of this in just 3 months? Well, we cheated, and we cheated a lot. Something else that you didn't see in the video was that if you refresh the browser, all of your visualizations, all the analysis would just disappear. And if you don't think that's a good feature, you're right. It's pretty awful, and it was one of our biggest complaints starting off. But I'm going to tell you why that doesn't matter by answering a different question. What is forward deployed product development that I'm in charge of, and why does that matter? In most B2B companies, the world is split into 2 different organizations. You have product development and you have business development. Business development has sales and sales engineers. And you have in product development, you have product managers and developers. The sales engineers go on site, install your product, and build whatever hacky solution is required to actually get the job done. In product development, they take that hacky solution, throw it away, and then rewrite a very architecturally sound system. FDPD is both those things. Any one of us are all the sales engineers, and product managers all into a single engineer. We could wear any of these hats at any time. And this isn't about titles. We don't see this as like a perk, but as a requirement to building a good product. A core value at Palantir is that we've actually put engineers in the field, unshielded from the raw signal and the raw problem. And we have found that engineers are best adapted to actually solve everything, if given the mission to actually be able to tackle that problem. And the reason for this is largely because there's no titles to delegate to. There's no MBAs to figure out what problem to tackle. It's just you in the field. And this is actually core to why we're successful. It's the notion that you need to be able to have the raw context of the problem in order to make the right decisions. Human communication loses so much about what the right problem is, or even nuances in design. And this is the reason why, this is why 3 of us could go out and despite having glaring bugs in our product, that signals intelligence analysts were actually using Contour 3 months in to find terrorists. But like our mandate isn't such that we build like a single solution such as signals intelligence product. To be a true product, we need to be able to be broad and diverse and used in many different places. So I want to talk to you about a different problem in a very different organization. Banks have many different kinds of risk alerting systems. And in this case, the system I want to talk to you about is the system that tries to detect traders from making very risky, very expensive trades. Unauthorized traders are traders who get around these systems. And these unauthorized traders are kind of something of like boogeymen. They keep the banks up at night. As you can see from the timeline, and this is only like a select few that I've actually put up here, is that these traders lose the bank tons of money. Either it's because they have lost money in the market or there's fines from regulators. Despite all the systems that banks have, all these unauthorized traders can get around them. And the most interesting thing is this isn't just like an instantaneous event. It's not like a trader wakes up one day and says, hey, I'm going to bet $5 billion on mortgages. It actually happens over time, where positions are slowly built up. And this is either because traders are trying to mitigate or reduce losses that they've already lost, or just placing big bets to get big returns. Basically, these guys are gamblers at the core. So why don't banks catch these things? And as it turns out, there's 3 different reasons. What banks try to do traditionally is map sort of all the trades that go wrong, such as after-hours trades or even canceled trades, and create like a stream of information and have basically the regulators try to figure out which traders are doing something wrong. And this actually fails in several different ways. One is if you actually go back to the timeline and look at why, and try to like map, if you can try to map why the traders have if you try to map back the trades that went wrong that cause these losses, they actually look very similar to trades that happen every day. For example, after-hours trades are just something that can happen through normal course of actions. Canceled trades happen all the time. It's very hard to figure out if a trader is doing something bad if you don't have the context around it. And the second is trades of very, very complex data that have come in very high volume. And the third is they have non-technical analysts that don't know SQL and they don't know how to code. And if this sounds familiar, we thought so as well. So we actually went into the bank embedded with the team that was writing the alerting systems to deploy Contour to the non-technical users. And we thought like the core use case here for us was to provide this tool for the regulators to say, hey, you guys are doing something bad, there was an alert. But as it turned out, we noticed something interesting in the usage data of Contour. It wasn't just the non-technical users that were using it. It was also the very, very technical people who were writing the alerting systems were heavily using Contour. And so we asked them, what are you guys doing? Like, we are very surprised to see this. You guys know how to code, you know how to write SQL. And basically Contour just does that for you instead, you're just clicking around. So they told us it's so easy to use, even though we can use pSQL to query like all our Postgres databases, it's much easier to use Contour. And this actually comes back to the interesting insight of humans and computers working together. Even the programmers who don't need us would rather not waste their brain power on writing out SQL and just use Contour. And this also comes back to a very important part where embedding with the customer and actually getting the full context of the problem is so important. Instead of just focusing on the non-technical users, we were able to now focus on these very technical people who are much more high value to the bank and also able to allow us to build new features that we'd never imagined before. So Contour today is deployed pretty much a core product at Palantir. 3 months in, we only had one customer in signals intelligence. A year later, we're in 10 different verticals across 5 different continents. And what does this mean? So I only have a few minutes left, and I could probably talk to you about an hour or two about our architecture or what technologies were used. Instead, I want to leave you with just 3 things that makes forward deployed product development so successful. And the first is find the right partner. This is just so very important to build products. Based on the expansion of Contour, we clearly had many different places where we could have possibly gone to build it. But you need to have a partner who's willing to guide you through the process. They have to be willing to get dirty in order to make it work. They have to be able to live with bugs. And the right partner has probably been trying to solve this problem for years and is not looking for the incremental solution. They're looking for the 10x solution that'll actually solve it. If your partner is more concerned about moving the search box 2 pixels to the left, you should run away. The second is cheat. And by cheat, I mean ruthless prioritization. Nothing is sacred. Anything can go. Most people think cheating is actually easier than playing it straight. It's actually much, much harder. Anyone can actually build a list of priorities to solve the problem. Only the people who have put in the effort to figuring out the context of the problem know which pieces they can completely throw away. And the third is, which is, I'm sorry, blatantly obvious, have a good team. Good teams are better than bad teams, but you really need strong engineers who have a good value compass. Do you remember the thing I keep talking about, the part where if you refresh the browser, all your visualizations would disappear? We ended up rewriting that. It involved re-architecting our front end and rewriting it from scratch. And it took the 3 of us only 2 weeks. Thank you.
Thank you very much, Adam. Any questions? Questions? Loud, please.
Wanted to ask you about this software. Is it being used in France right now?
So I can't talk about specific customers, but maybe. So 2004, it's about 11 years. So it's quite old.
Okay, thank you very much, Adam, for being here with us.